All right, good morning. Let's take a look at your Chapter 3 review here. So the first objective basically takes a look at graphing quadratic equation, identifying, basically I know here it says the max and minimum values, but it's also identify key features of your quadratic function. So there's four problems in this section that we're going to go over real quick here. So on number one here, it says given this quadratic equation, f of x equals negative 3x minus 4 plus x squared. Hopefully you see that, oh wow, this is out of order. When we deal with quadratics, it's very important to get it in this ax squared plus bx plus c form. So I'm just rewriting my parabola here. Sorry about that, got to get into pen mode. So let me change colors too. So f of x, we get f of x equals, we put the x squared term first, x squared minus 3x minus 4. Then, once it's in that form, identifying the a, b, and c becomes pretty easy. Your a value is the number in front of the x squared, so a is 1. B is the number in front of the x, minus 3. C is the constant, or just the number without any variables. C is negative 4. Find the y-intercept. Well, remember, c is the y-intercept. So it's when x is 0, the y value, or the function value, is negative 4. So now it says find the equation to the axis of symmetry. Remember that axis of symmetry is x equals negative b over 2a. Hence why it's so nice to be able to write and identify a, b, and c right away. So as I plug those values in, negative 3 becomes positive 3 over 2 times 1 is 2. So x equals 3 halves, or if you wrote 1.5, that's fine too. So now it says find the x-coordinate of the vertex. Well, that is 1.5. That's what this value is the x-coordinate. I know it doesn't ask you to do this, but I'm going to actually find the vertex so that it helps me with the last part of this question. So to get that last part, I'm going to plug in 1.5 in for x. I'm just going 1.5 squared minus 3 times 1.5 minus 4. So you can plug that in your calculator. So all I'm doing is going 1.5 squared minus 3 times 1.5 minus 4. That gives me negative 6.25. So that's very helpful for this next part because now I know where the vertex is located. So I'm going to put that in the middle part of my table. 2, 4, 6. I apologize. I think most of you know that I've added an extra piece here. So I'm going to put that right in the middle, 1.5, negative 6.25. So to get other points, on the other side of 1.5 would be 1, 0, negative 1, 2, 3, 4. So this is where I use my calculator a lot here. So I'm going to go to my equation here and type it in. Right? So it was x squared minus 3x minus 4. And I'm going to graph it. Use your graphing calculator to help you out. So I get a nice picture of it so I can kind of see where it's at. I'm going to use my table to get all of those values. So I can see at 1 it was negative 6, then negative 4, and 0. Going the other way, it's the same thing. I notice that symmetry. Okay? And so now I can graph these points. Negative 1, 0, 0, negative 4, 1, 6. Then it goes down to about 6.25. Then I get the other 3 points on the other side. So I can draw myself a nice parabola. All right, so that takes care of number 1. On number 2 and number 3, you just want to, again, use your technology to help yourselves. So here I'm given this function. First thing I'm going to do is rewrite it in general form. So 3x squared minus 2x minus 8. So since the a equals 3 and it's positive, I know that this value is going to be a minimum because a is positive. So now it says state the maximum or minimum value of the function. This is the vertex. So I just need to find the vertex. So just like I was doing up top, okay? So x equals negative b over 2a. So the opposite of negative 2 is 2. 3 times 2 is 6. 2 6 1/3. So I have 1/3 here. So now plug in 1/3 right here into the equation. So I'm going 3 times 1/3 squared minus 2 times 1/3 minus 8. Yeah, it's a messy fraction, but this is where our technology can come and help us out. So I'm just going to plug this in. 3 parentheses 1 divided by 3 squared minus 2 times 1 divided by 3, and then subtract 8. So I'm just checking just to make sure everything looks right. It's going to give me a decimal. I can go math, fraction, and look at that, negative 25/3. So if I'm visualizing what's going on here, I have a parabola that's opening up. There's my vertex, okay, is that point. So for my domain of my function, we know that the domain of all quadratics go from negative infinity to positive infinity. For the range, it all depends on if it's opening up or down. Since this is opening up, it goes from the y-coordinate of the vertex all the way to positive infinity. So I'm going from negative 25/3 all the way up to positive infinity. I get my domain and range. Okay. All right, the second one, or question number 3, done in a similar fashion. Okay. What's nice is this one's already in the form, so I know that this one, a, equals negative 2, so this one I know is a maximum because my a value was negative. So now, since I know it's a maximum, I know it's opening up, down. So again, to find that vertex, x equals negative b over 2a. So I have negative 1, so a positive 1, over 2 times negative 2. So I get negative 1/4. So now I'm going to plug in negative 1/4 right in here. So I'm going negative 2 times negative 1/4 squared minus a negative 1/4 plus 10. Plug it into your calculator. So I'm just going to do that. Negative 2 parentheses negative 1 divided by 4 squared. Then it says minus, in parentheses, negative 1 divided by 4. So use your parentheses as your friend. Plus 10. So I get 10.125. So I'm going to go math, fraction. I'll convert it to a fraction for me. 81/8. Yeah, not a very nice answer. However, that's the highest y value, 81/8. So when I look at the domain, again, quadratic goes from negative infinity to positive infinity. The range is going from negative infinity up to that value. So negative infinity, comma, 81/8. So if you look at these two, notice how it opens up. It starts at the y-coordinate, goes to infinity, but if it opens down, it goes from negative infinity to that coordinate. All right, let's take a look at the second page, which is our last problem in this objective. So here it says a local theater group can sell 1,000 tickets at $40 to their upcoming performance. They estimate that each $10 increase in ticket price will decrease their ticket sales by 50 tickets. How much should they charge per ticket in order to maximize their income from ticket sales, and what is the maximum income they can expect to make? All right, so we've done a few of these types of problems. So we're going to have x equal the number of price increases. Okay. So remember that income, we can figure out how much we're basically making here by taking the price of the ticket and timesing it by the number of tickets. So what I need to do is write an expression for both of these in terms of x. So I of x, the income based on the number of price increases, well, I start by charging $40, and I'm going to add $10 for each price increase. I'm now going to multiply that by the original 1,000 tickets, but for each increase, I decrease by 50 tickets. So 1,000 minus 50x. So now I have my quadratic equation. I just have to FOIL. So as I FOIL this out, 40 times 1,000 is 40,000. I multiply my outsides, minus 2,000x. Multiply my insides, 10,000x. Multiply my last, minus 500x squared. So I'm going to rewrite this in general form, meaning I'm putting my x squared term first, combining like terms, so I have 8,000x plus 40,000. My goal here is to find the maximum. So looking at this, because I know that A is negative, I know my vertex is a maximum. So I want to find that vertex value. So it's going to tell me how many price increases I need to make, and it'll help me find the income. So the first thing I want to do, I'm just going to go x equals negative b, so negative 8,000 over 2 times negative 500 is a negative 1,000. So that tells me I need to make 8 price increases. So if I make 8 price increases, I need to find I of 8. So negative 500, 8 squared, plus 8,000 times 8 plus 40,000. Plug this into your calculator. So I'll do this one more time. Negative 500 times 8 squared plus 8,000 times 8 plus 40,000. That should give me 72,000. So I of 8 equals 72,000. So now I know the income is going to be $72,000, but I also want to know what the ticket price would be. So I got to go back to here where I have ticket price, and remember that the price of the ticket that I should be charging is 40 plus 10 times 8. So the ticket price is going to be $120. All right, that takes care of the first objective. Going on to the second objective, again, we're still graphing. We just want to be able to also estimate the solutions. So on these, your calculator is going to be huge. Okay? So as it says here, number 1, solve x squared minus 8 equals negative 2x by graphing. So to switch it to standard form, I got to move that minus 2x over. So x squared plus 2x minus 8 equals 0. So I'm going to right away plug this into my calculator. X squared plus 2x minus 8. I'm going to go ahead and graph it. Wow, if I look at this, I can actually start to see where my zeros are located here. Not only that, it looks like my vertex down here is at about negative 1. Okay? So what I'm going to do is I'm going to go to my table. I'm going to look at right around negative 1, and look at that. Right there at negative 1, it's my lowest point, negative 9. So for this table, I'm going to add an extra, and so extra box, sorry, and put in here negative 1, negative 9. So then I have here negative 2, negative 3, negative 4, 0, 1, 2. So again, negative 8, negative 5, 0. Negative 8, 5, negative 5, 0. So I can go ahead and graph those points. Negative 4, 0. Okay. Negative 3, negative 5. Negative 2, negative 8. Negative 1, negative 9. Whoops, I didn't go so far. I didn't go quite all the way down, so let me remove that point. There we go. Then I'm down here, and then I do the same thing back up. I have my parabolic graph. So again, what are we looking for? Where it crosses the x-axis. So where f of x is 0, so my solutions are x equals negative 4 or x equals 2. All right, let's take a look at the second one. Same process, just got to get it into standard form. So I have negative x squared minus 6x. I got to subtract 9 so that it equals 0. Ooh. So now, let's graph it. So clear this out. Negative x squared minus 6x minus 9. Go ahead and graph it. Look at that. The parabola looks like it's touching right at the vertex there at, I think it looks like it's at about negative 3. So I'm thinking that value is going to be at about negative 3. So I'm going to go to my table, and sure enough, look at that. At negative 3, it's at 0, which is really nice because in essence, I've found my one solution, x equals negative 3. Sorry about the bells. Those will come from time to time here as I'm doing the video during my prep time. So I'm just filling in the rest of the table. So again, I'm just going negative 1, negative 4, negative 9 in both directions. Many of you shouldn't realize as I graph this, I start at negative 3. As I go right and left, I'm going down 1, and then down 3, and then down 5. So I get a nice picture of my parabola. Only one solution there. Okay. All right. On the last example, or last one with the graphing part here, says solve this one by graphing. So this one, it's asking you the consecutive integers where the roots or zeros are located. So this one's not going to give you for a very, very nice answer. So I'm going to type it in here first. So I go x squared minus 4x plus 2. Go ahead and graph it so I get a picture of it. So it kind of looks like it's between 0 and 1 and 3 and 4 as I look up in here. So between 0 and 1, between 3 and 4. So to help me with my table, okay, I'm going to try to focus right around those values here. So you can see we start to get it repeating here. We actually find the vertex there at 2, negative 2. I'll put that right in the middle, 2, negative 2. I'm going to get the rest of my, so 1, 0, negative 1, 3, 4, 5. So I'm going to copy the rest of the numbers here. So negative 1, 2, 7, negative 1, 2, 7. So what I can start to see is one solution, well, I'm looking at where 0 would be located. So it'd be somewhere in between here, between 0 and 1. The other solution then, as I saw, is between 3 and 4. And again, you do have the graph here, so I'll quickly graph this. So my vertex again was at 2, negative 2. So left 1, right 1, then up 3, left 3, up 5. So you can see how I graph that pretty quickly, but we can start to see one solution is somewhere between 3 and 4. The other solution is somewhere between 0 and 1. All right, last problem in this section, solving by using a calculator. Oh, an Olympic diver will perform a dive from 10-meter platform, which is approximately 32.81 feet above the water. How long will it take the Olympic diver to reach the surface of the water, assuming there is no air resistance? Use the formula where T is the time in seconds and H sub 0 is the initial height above the water in feet. Wow. Okay, so to do this problem, I'm going to take that equation, H of T, so I get negative 16 T squared, but the H sub 0 is how high the diver, okay, is above the ground. So I can substitute in 32.81 feet. So what I want to do, okay, is figure out, okay, where this diver is hitting the ground. I'm wondering, sorry for that, where it equals 0. So one of the things I can do is set this equation equal to 0. Is if I'm visualizing what's happening here, in essence, here's the diver, and they're falling into the pool, and I'm looking at how long it takes to get there. So I'm just going to solve this equation for x. So what I'm actually going to do is I'm going to add 16t squared to both sides. You could actually move the 32 to the other side, but if I do that, then everything here is positive. Now I'm going to divide everything by 16. So I get t squared to equal, okay, so now I'm just going to exit out of this table, clear out my screen for a second, 32.81 divided by 16, and I get t squared to equal 2.05 dot, 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 dot. I'm going to keep that on my calculator, and I'm going to square root. Technically, I would have plus or minus. Since we're talking about time, time can't be minus. So I'm going to take the square root of my answer, and I get 1.4 plus or minus 1.43. Since we're talking about time, it would take about 1.43 seconds. Wow. Doesn't take long for an Olympic diver to hit the water. All right, so that takes care of section 3.2. Section 3.3 is all about complex numbers. So basically, we have one example of each here just to review. So like on the first one, it says square root of negative 144. Remember, the whole process of imaginary and complex numbers is that I is equal to the square root of negative 1. So when I see the square root of negative 144, I'm going to get an error on my calculator. But what I can do is break it up to the positive 144 and the square root of negative 1. Square root of 144 is simply 12, and then square root of negative 1 is I. All right, number 2, adding. It's pretty easy. Look at what you're asked to do in between the two sets of parentheses. Here we're asked to add. So I'm going to add the real parts. 4 and 9 make 13. 3i minus 5i make 2i. On the second one here, it's subtraction. So 7 minus 3, 4. Negative 2 minus 6 more makes negative 8i. Multiplication, here's where we FOIL. And remember that I squared is equal to negative 1. So if I go up here and square both sides, the square and square root cancel, making I squared, okay, would be the square root of negative 1 squared. Those cancel, hence why I squared is negative 1. So again, I'm going to FOIL this. 2 times 5 is 10. Multiply the outside, minus 8i. Multiply the insides, 15i. Plus, and then minus 12i squared. So when I go to simplify this, this negative 12i squared becomes a positive 12. 12 and 10 make 22. Negative 8 and 15 make 7i. All right, let's take a look at the last one. The last one is we can't have i's in the denominator. So when we're dividing, we multiply the top and bottom, by the conjugate. So we'll multiply the top and bottom by 7 plus 2i. So when I multiply the top, we get 28 plus 8i. In the bottom, when you FOIL, you get 49 plus 14i minus 14i, and then minus 4i squared. The middles will cross out. This will become plus 4. So I get 28 plus 8i all over 53. All right, that takes care of, I apologize. Go on to the next page here. We got 2 more problems where 3.3. So here now you're asked to solve each equation. So just undo operations, do your inverse operations. So we subtract 80 from both sides. I have 5x squared equals negative 80. Divide by 5. X squared equals negative 16. Square root both sides. So x equals plus or minus the square root of negative 16. Remember, we can write that as 16 and the square root of negative 1. So I get x equals plus or minus 4i. Same process on the second one. Subtract 75. So 3x squared equals negative 75. Divide by 3. X squared equals negative 25. So then when I square root both sides, I get x equals plus or minus the square root of negative 25. So again, 25 and negative 1. So x equals plus or minus 5i. So anytime you're doing problems and you have a negative square root now, what that means, is that you're going to have imaginary solutions. All right, so that takes care of 3.3 objective. All right, continuing on. We still got a few more pages to plug away. So in 3.4, solving quadratic equations in standard form, and you'll be able to not only write them, but to be able to solve them. So here we start with having the given roots. So if you think about how we like to do this, we start by saying, well, x equals 5 or x equals negative 3. So what we do is move the 5 over and the negative 3 over, so we get the factors x minus 5 and x plus 3, and we set them equal to 0. Then it's just a matter of FOILing. So you multiply the first, the outsides, the insides, and the last. Combine like terms. So I get x squared minus 2x minus 15 equals 0. I have my solution. On the second one, you got that fraction 1/3. X equals negative 2. So when you do this one, you have to first multiply by 3. So you get 3x equals 1. Subtract the 3. So you have 3x minus 1. Here we're just adding the 2. And it equals 0. So again, FOIL. 3x squared. Outside, plus 6x. Inside, minus 1x. Last, minus 2. Combine like terms, 3x squared plus 5x minus 2 equals 0. And I have my quadratic equation. So the last one is just the same process. X equals 5. X equals negative 1/4. So I have x minus 5, move that over, negative. So again, multiply by 4, so I get 4x, but minus 1 over becomes plus 1. So now again, FOIL, 4x squared plus 1x minus 20x minus 5 equals 0. So I combine like terms, 4x squared minus 19x minus 5 equals 0. All right, so the next section here, it says to solve each quadratic equation by factoring. So this has a whole bunch of ones that are mixed, okay? So when I look at any of these problems, I always think of greatest common factor first. But when I just see an x squared and it's a trinomial, I'm always thinking of the last term, factors of the last term that add up to 9. So I sit there and go through my factors, 1 and 20, 2 and 10, 4 and 5, and I realize that, 4 plus 5 is 9. So I get x plus 5, x plus 4. Doesn't matter which order you write it. So then we use the zero product property, set them each equal to 0, and solve. So x equals negative 5, or x equals negative 4. So if I look at the next one is a little more challenging for some because it's not 3 terms, but I look at what they share in common. Well, they share a 5 and an x. So when I pull out both the 5 and the x, I'm actually just left with x minus 6. So once I have it as 2 things multiplied together, set them each equal to 0, and solve. So I divide by 5 and I just get x equals 0. Here I get x equals 6. So many times when you're solving these, not all the time, but many times, you're going to get 2 solutions. All right, this one. Well, this one you're actually looking at factors of 36 that add up to 0. So many of you will realize, they're just opposites of each other. So this factors to x plus 6, x minus 6 equals 0. So x plus 6 equals 0. X minus 6 equals 0. So x equals negative 6, or x equals positive 6. All right, the last 3, same process. I look at the first one, it's still just an x squared, so I'm looking at factors of negative 30 that add up to negative 7. So 1 and 30, don't. 2 and 15, that would be negative 13 if I made one positive, one negative. 10 and 3, if I go 3 and negative 10, that's going to give me my negative 7. So I have x plus 3, x minus 7 equals 0. So set them each equal to 0. So I get x equals negative 3, or x equals positive 7. All right, the last 2 are the challenging ones because now you have a leading coefficient other than 1. It's a 2. So what we're looking at here is not factors of 12, but 2 times 12, which is 24. That adds up to 11. So I sit there and go through. 1 and 24 add up to 25. 2 and 12 add up to 14. 3 and 8, 3 and 8. So what I do is I break up this 11 as 3x plus 8x. Bring down the first term, 2x squared. Bring down the last term, 12. And then I do what I did in C is I factor out what they have in common. So this has an x in common. 2x plus 3. This has a 4 in common. Notice how you'll have 2x plus 3. This works only if they're the same inside the parentheses. So now I have x plus 4 sets of 2x plus 3's. So now I can do the zero product property and set them each equal to 0. So I get x equals -4, or x equals, subtract the 3, divide by 2. All right, let's look at the very last one. Same process. Factors of -30, because it's 3 times -10, that add up to -1. So I'm trying to really think of two numbers that multiply to 30 that differ by 1. If I go +5 and -6, I believe that works. Okay? So what I can do is rewrite that -x, okay, as -6x, but +5x. Bring down the -10, bring down the 3x squared. So now, factor by grouping again. They have a 3 and an x in common. I'm left with x minus 2. These two terms have a 5 in common. I'm left with x minus 2. I apologize, this still equals 0. So I get 3x plus 5 sets of x minus 2's. That equals 0. So set each factor equal to 0. So I get x equals -5 over 3, or x equals 2. All right, so that should take care of the factoring in 3.4. I would expect, a problem like A or B. I would expect a problem like C, okay, or maybe E, and then one like D where it's the harder one. I would expect a couple of those problems on your test on Wednesday. All right, let's take a look at the next page, the next objective. So it's now doing the square root property and completing the square. So on these first questions, it says, find the value of C that makes each trinomial a perfect square. Remember how this process works. We take half of the value, so half of -10 is -5, and then you square it. Well, -5 squared would make C 25, because this would make this x minus 5 quantity squared. So half of 5 is 5 halves. 5 halves being squared, 25 fourths. So that's what C would equal. On the last one, half is -1.2. -1.2 being squared makes C a positive 1.44. So that's all you really had to do was find the C values on these. So now, completing the square. So, let's take a look at these here. Let's take a look at the first one here. So again, the process of completing the square. Move the 16 to the other side. X squared plus 6x, leave a little space, equals 16. So now you do this process of completing the square. We've talked about this many, many times in class. Half of 6, 3. 3 squared is 9. If I add 9 to this side, I have to add 9 to the other side to keep it balanced. So I get x plus 3 quantity squared equals 25. Now the reason why we're writing that is now we can use the square root property. Take the square root of both sides. Square root, plus minus. I'm just left with x plus 3 equals plus or minus the square root of 25 is 5. Now I can just subtract 3. X equals -3 plus or minus 5. So -3 plus 5 is 2. -3 minus 5 is -8. All right, let's take a look at the next one. Same process. Okay, move the -14 to the other side. So x squared minus 8x equals 14. Complete the square. Half of negative 8 is negative 4. Negative 4 squared is 16. I'm going to add 16 to both sides. So now this factors to x minus 4 quantity squared equals 30. Undo the square now, doing the square root property. So I get x minus 4, so I'm going square root, don't forget plus minus. So x minus 4 equals plus or minus the square root of 30. Add 4 to both sides. So x equals 4 plus or minus the square root of 30. Now, the square root of 30 has no perfect squares in it. Okay? The only factors are 2, 3, 5, and 10. None are perfect squares, so we're good to go. All right, letter C. Oh my goodness, letter C is the hardest of them all. I will tell you right now, you will not have one like this on the test. We will make sure that that middle number is an even number. But since it's on the review, I'll show it to you anyway. We'll move the minus 2 to the other side. So I get x squared minus 3x equals negative 2. So take half, so I get negative 3 halves. Square it. Negative 3 squared is 9. 2 squared is 4. So I have to add 9 fourths to both sides. So I get x minus 3 halves quantity squared equals, if I add those together, I get 1/4. So now, square root both sides. So if I square root this side, square root this side, plus minus, I have x minus 3 halves equals plus or minus, well, the square root of 1 is 1. The square root of 4 is 2. Ooh. So now all I have to do is add 3 halves to both sides. So 3 halves plus or minus 1 half. Well, 3 plus 1 is 4 divided by 2. Well, that makes x 2. 3 minus 1 is 2. 2 divided by 2 is just 1. So even though this had some messy fractions at the beginning, it ends up being a nice number. All right, let's take a look at the last two. All right, so on this first one here, now notice that we got a 2x squared. First step, however, is the same step. 2x squared minus 24x, leave a little space, equals negative 64. But here, when you have that leading coefficient, you want to factor that out. So I have x squared minus 12x, leave a little space, minus 64. Now I'm going to complete the square. Half of negative 12 is negative 6. Negative 6 squared is 36. But to balance it, I actually have to add 2 times 36, or 72. So now I have 2 in parentheses, x minus 6 quantity squared. Add those two together, and I get 8. I now have to divide both sides by 2. So I have x minus 6 quantity squared equals 4. Square root both sides. X minus 6 equals plus or minus, so I'm going to square root both sides. So I get plus or minus 2. Add 6 to both sides. So now I get x equals 6 plus or minus 2. So x equals 8, or x equals 4. All right, last one in this section. What's nice is this is already set up for me where I'm already factoring out the 3. So I have x squared minus 1x, leave a little space, equals 60. This one's not so nice at first because half of negative 1 is negative 1/2. Negative 1/2 being squared is 1/4. And this is kind of mean. 1/4 times 3 is I'm adding 3/4 to this. So this factors to 3 x minus 1/2 quantity squared equals, so this is where I'm going to have my calculator help me here, or at least show you where I'm getting the next value. I get 60.75, but if I go math and change it to a fraction, it'll change it to 243 over 4. Okay? Now I got to divide both sides by 3. So I get x minus 1/2 quantity squared equals, well, if I divide by 3, if I go divide by 3, it changes it to 81/4 for me. So now when I square root plus minus for me, I have x minus 1/2 equals, well, the square root of 81 is 9. The square root of 4 is 2. So now I have x, add the 1/2, 1/2, plus or minus 9/2. Well, 1 plus 9 is 10. 10 divided by 2 makes x equals 5. 1 minus 9 is -8. -8 divided by 2 makes it -4. Trust me, on your test, you will not have one that deals with fractions. It'll be more like letter D. Okay, so expect one like that. Expect one like A or B. All right, let's take a look at the very last page, objective 3.6, which deals with the quadratic formula. Can you identify the discriminant? Tell me how many solutions there are going to be, and then use the quadratic formula also to find your solutions. So part A is just doing the discriminant. The discriminant is the b squared minus 4ac part. So again, identifying A, B, C. So when it's in this nice order, we're just plugging this in. So I'm going -5 squared minus 4 times 4 times -2. So as I simplify this, I get 25, and this ends up becoming plus 32, so I get 57. So since 57 is not a perfect square, I get 2 real irrational I almost forgot the AL, roots. So on the second one, I'm doing the same thing. So I'm plugging in, so I'm getting 2 squared minus 4 times 5 times 4. 2 squared is 4 minus 80 gives me -76. So if it's a negative, I have 2 complex roots. On the last one, I have 8 squared minus 4 times -1 times -16. So that gives me 64. Well, a negative becomes a positive, becomes a negative. Minus 64 ends up being 0. So if I get it to be 0, I have one rational root. So remember, if it's a perfect square, we say it's rational. If it's not a perfect square, we say irrational. All right, last problems, quadratic formula. You got to know this formula. We're expecting you to know it and have it memorized. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So on the first one, I'm just plugging in those values. X equals -45 plus or minus the square root. Wow. 45 squared minus, again, 4 times 1 times 200 all over 2 times 1. So 45 squared, wow, 3225 minus 2000. So I have x equals -45 plus or minus the square root of 1225 all over 2. Well, the square root of 1225 is actually a nice number. Plus or minus, you actually want to check it out, square root of 1225, look at that, you get 35 all over 2. So -45 plus 35 is -10. negative 10 divided by 2 is negative 5, or x equals negative 45 minus 35 is negative 80 divided by 2, we get negative 40. All right, let's do number 2. In order to do number 2, we got to get it all to one side. So I need to add 7 and add 4x to both sides. So I get 4x squared plus 7x minus 5 equals 0. So all of this crosses out. So now I'm going to plug it into the quadratic equation. I'm going to move this up so I got a little more space. X equals negative 7 plus or minus the square root of 7 squared minus 4 times 4 times negative 5 all over 2 times 4. We get x equals negative 7 plus or minus the square root. Let's see, 7 squared is 49. Negative 4 times 5 actually makes positive 80. So 49 and 80 make 129 all over 8. Here's the beautiful thing about this one. 129 has no perfect squares in it whatsoever. So we're actually done. Nice. All right, let's take a look at the very last one. So I'm just going to change colors for the last time here. So again, plugging it into the quadratic formula. X equals positive 3 plus or minus the square root, negative 3 squared minus 4 times 3 times 8 all over, all over 2 times 1. So as I plug this in, I get 9 minus, that's what, 96, I believe? So let's see, here we go, negative 4 times 3 times 8 makes it that we're subtracting 96. Wow. Okay, so 9 minus 96, negative 87. So I have x equals 3 plus or minus the square root of negative 87 all over 2. Well, the negative can be taken out. 87, 3 goes in it. Okay, but the only problem is 29 isn't a perfect square, neither is 3. So all I can take out is that I. So I'm left with 3 plus or minus I square roots of 87. If you're checking the key online, my key online has this 87 as 23. That is a mistake that I made because I accidentally put 1 here instead of 3. All right, that ends your review. Good luck on your test tomorrow.